Module 8, Lesson 2, Resource Controls and Resource Pools. After this lesson, you should be able to assign share values for CPU and memory resources, describe how VMs compete for resources, be able to create a resource pool, set resource pool attributes, and establish CPU and memory reservations and limits, and describe expandable reservations. So a virtual machine powers on only if its reservation can be guaranteed. Defining the resource settings for individual VMs. So we can go in and edit a virtual machine, and we can set the settings based on just that virtual machine. So what we do here, we think of virtual machines as resource consumers. The default resource settings that we assign work well for most machines. As you can see, each one has a share. So we can see between VM A, B, and C here, that's 3,000 shares worth. We can change the number of shares. So right here we change B to 3,000. Well, it's going to be guaranteed 3 times more than C and A. Same thing down here when we power it on this option. But now you got to look, we've added a VMD that has another 1,000. So now that host is going to need 6,000 shares. We power it off, we only have, on this one, power off VMC, we only have 5,000 shares in use. So we can use resource pools to help manage resource settings and guarantees and reservations. And this is basically, we're adding a hierarchy of a resource pool here. Now you can always think about this, a host and a cluster is a resource pool. In a cluster, this is the root resource pool. Now we have sibling resource pools as compared to the root or the cluster. But now you can also consider these parent resource pools, and then if we create another resource pool under it, that's the child. Now again, like we seen a couple slides ago, this window here looks sort of like what we did per VM. What this does is we set up these shares and reservations on a resource pool, and then we add machines to that resource pool. We want to use a resource pool to have a flexible hierarchical organization, isolation between pools and sharing into pools. You can use them for access control and delegation because it's basically another object that's going to have objects underneath it. We can separate the resources from hardware, and we can manage sets of virtual machines running in a multi-tier service, and it gives us the ability to prioritize virtual machine workloads. Now there's one comment I always make about resource pools. If you have an ESXi host and I have 5 machines running on it and I don't touch anything to do with resource pools or VM settings on reserving resources, then basically those 5 machines have full control of that host. When you start adding reservations, I look at it as you are slowing the system down, because in some ways, just think of it as now instead of that one VM having however much access to that ESXi host, now I'm actually restraining it and saying I'm going to only reserve you this much. But if you have a bunch of machines contending for it, you're going to need to start using this because you have some that are more important than others. So I just like to point that out. You're actually starting to cut down on what that machine can use. You still do have problems like if I've only got one CPU in that machine or a virtual machine, then it's not going to be able to utilize all the CPUs on that host. I could add another CPU to it, but that also gives it another share because that's another resource it's using, which then if I have a machine with 2 CPUs versus another machine on that host with 1, the one with 2 is getting more resources than the one with 1. So this is a way to organize all of that. So in this example, we have an engineering pool with 4,000 CPU shares. We're going to reserve it at 1 gigahertz. We're going to limit it at 4 gigahertz, but we're going to let it be expandable. And we're going to create a test. We got a test VM underneath it, and we got a production. Now, our CPU share is going to be 3,000, so that'll work. It's going to reserve, this one's reserved at 250, where we're good here because the pool is reserving 1,000. And we're going to limit it to 4,000. So it needs to match what the parent's going to be. And again, you also have this going up to what the host is going to be of the cluster. So now in this example, the finance pool has 8,000, engineering pool has 4,000. So all that does is, it's not really a number, I mean it is number of shares. What this is saying, the relation is the finance pool is twice as many CPU resources than the engineering pool has. Now here we're seeing contention. All these VMs are running on the same physical CPU. And this guy's getting, engineering's getting 33 and finance is getting 67. So what we end up, we have 11% of the physical CPU available. An expandable reservation. Expandable means it's going to stay in these limits, but if it needs it, it's going to raise them. So it gives us makes it flexible. But the thing is, if you do this and it uses it and expands it, the expansion will stay there until the machine that caused it to expand is shut down or the reservation's reduced. In mission control for CPU and memory reservations, you power on a virtual machine, create a subpool with its own reservation, or increase a pool's reservation. It always checks, can this pool satisfy the reservation? If it can, then do it. If it can't, is it expandable? If it's not an expandable reservation, then no, it's going to fail and not power on. If it is expandable, then go to the parent pool. Can it satisfy it? If it can, then good. Then we'll go back to succeed. We can look at our resource pool summary on the summary tab when you click on a resource pool. We can look at the reservation by clicking on the monitor and resource reservation. Now we can also schedule changes to resource settings. In this example, let's say around 3 o'clock, we get hit harder and our virtual machines need more memory and CPU. So we can schedule it to say, hey, in this example I'm using, or is on the slide, 2:47, let's start ramping up the reservations so our systems will run quicker. Now you should be able to assign share values for CPU and memory resources, describe how virtual machines compete for resources, create a resource pool, set resource pool attributes, establish CPU and memory reservations and limits, and describe expandable reservations.